In this video, we'll discuss about the redundancy of the valve. In one of our previous lecture, we have discussed about the redundancy of the transmitters and what are the different configurations are. In this case, we will be discussing redundancy of the valves. Though it seems quite simple, sometimes depending on the failure modes and the safety action of the valve, it's get quite confusing. So, in the coming slides, with the help of the animations, I have tried to show you what different combination can be and what is the safety and availability scenario in each of the cases, and what is the most suitable combination of the valves that you can use for your particular purpose, right? So let's begin with it. So in most of the cases, if you see PNID, there is a single valve is being used. So this assume that this is a single valve and this is a failed close and normally open valve. So failed close means whenever there is any issue in the valve, maybe there may be wire breakage, there may be issue with the air supply failure, or maybe there is some issue with the positioner. Anything happens, the valve will be closed, right? But in normal condition, when the process is running, the valve is in open condition. So assume that this is the flow direction and the safety action of the valve is closing or isolating the process. So maybe think the valve is carrying some fluid into some equipment, and safety action is closing of the valve, because in case of failure we will not be able to close the valve, right? So if it remains open, it will overflow the vessel, that will create a hazardous situation. So in this case we are assuming that the valve is normally open and failure action is closed. So when only a single valve is used, this combination is known as 1 out of 1 combination. Now there is another combination as shown in the figure, which what you will call this combination, whether it is 1 out of 2 or 2 out of 2 for this particular scenario. Just pause for a moment and try to understand or try to infer what is this combination. Okay, so by now you must have decided what this combination is. Now look at the answer. This is a 1 out of 2 combination in this particular scenario. Why? Because in case of failure of any components in the valve will close. One of these two valve will close, and this will make the process to be isolated, or the flow of the liquid will get interrupted, and there is no chance that the downstream vessel or equipment gets flooded. So this particular combination is 1 out of 2. Then what is this combination? This combination is 2 out of 2, because in case of fail of one valve, the other valve will remain open and allow the process to continue. So for the safety action to take place, both the valve needs to be closed, right? Then there is another combination. So here you can see it is a 2 out of 2 combination between 1 out of 2 combination, right? So there are there are two valves that are in series, and there is a bypass line, and in the bypass line there is again two valves, right? So process to get interrupted, at least one valve from each of the line have to be closed, right? So even if in one line two valves are closed, from the other line the flow may still occur. So this is a 2 out of 2 combination between 1 out of 2 system. Now, what are the benefits of each system? So this 1 out of 2 system provides better safety, because if any of the valve closes, it cuts off the feed to the equipment, thus protects the equipment. So this provides better safety. On the other hand, consider the situation 2 out of 2. In this case, even if of any failure action or spurious case, one of the valves gets closed, the other valve is still open. So flow continues through this valve, right? Making the process more available. And on the last case, it is a good combination of safety and availability, because in case any of the two valve, right? So the in case of any of the two valve or from each of the line gets closed, it isolates the process. So this is a good combination of safety and availability. Now you will see that this physical, by only seeing the way they are physically, these valves are physically laid out, we cannot conclude whether this is a 1 out of 2 system or 2 out of 2 system. It depends on the failure action of the valve, and also what is the normally open or normally closed condition of the valve, right? So we will see from another example. So this is another example whether there is a single valve, but in this case it is fail open. The valve is fail open and normally closed. So for example, you can see this can be a deluge valve in the fire water line, which normally remains closed, but it opens when there is a fire or there is a demand. This valve opens, right? So this is the 1 out of 2 combination, and this is, and now see this, what combination is this? Earlier case this was a 1 out of 2 combination. Now whether it will be 1 out of 2 combination? No, it will be 2 out of 2 combination. Why? Because normally these valves are closed. Okay, now whenever the failure occurs, one of the valve will open, but this will not allow the liquid to flow or the fire water to the flow to the fire, because the another valve is there in the series and that will obstruct it. So, and this is another combination, and this is 1 out of 2 combination, because both, if any of these two valve opens, right, due to the failure action, the water will go to the fire, and that will perform the safety action, right? And there is another combination. This is the 2 out of 2 between 1 out of 2 systems. So first one is providing better availability, obviously. What is the second one is providing? Better safety, because if any of the valve gets failed, it gets open and it allows the fire water to flow Whether there is a fire or not, that is a different situation, though definitely there will be wastage, or but safety is maintained in the case of the failure, right? And obviously this combination, two valves in series and they are in parallel, then this combination is a good example of safety and availability. Hope you have understood the two situations, and by merely seeing the valves from the PNID, we cannot confirm that whether these valves are in 1 out of 2 or in 2 out of 2. We need to see the failure actions of the valves also, whether they are fail close or fail open, and whether the valve is normally open and normally close. So just be careful in selecting the type of the valve, right? So that's it from this particular lecture. Thank you for watching.